video, I'm going to show you how to bench test this fan motor. This is a DC fan motor out of a GE fridge, and it has 4 wires running to it. You can test these in the fridge as well, using the same process. If you run into problems where you're not sure if it's the fan or not, or maybe the control board or wiring, this is a quick test you can do just to see if the fan itself is working. So this fan runs off of 12 volts DC, has 4 wires. If you were testing this in the fridge, you'd be looking for 12 volts constant from the control board through the red wire. Yellow wire, you're going to have a variable voltage from the control board, and that's going to be the fan speed. It's going to be controlled by that. White wire is going to be your negative DC, and the blue wire is going to be your fan speed coming back from the fan to the board to let the board know how fast the fan is spinning. Don't get caught. I've been caught by these before because I'm lazy. I'll get in there with my voltage sniffer and I found voltage, thought okay, I got voltage and fan's not going, must be the fan motor. Put a fan motor in it, still didn't work. You got to dig a little deeper. So in this case, we're out of the fridge. We're just going to test the fan by itself to verify the fan's working. Okay, to do that, we're going to do it with a 9-volt battery. Now I know this is a 12-volt fan, but a 9-volt battery will do. These fans will run on a 9-volt battery. Okay, to start testing, we need the red wire, which is our constant 12 volt. So I'm going to put my red lead in there. I'm going to take my fused jumper wire here, and I'm going to jump across to the yellow. We need that power over on the yellow wire too. So we're going to feed 9 volts both to the yellow as well as the red. And that will give us full fan speed. Underneath the black wire, we're going to put the black wire to the DC ground, which is the white wire. So black is going to go to negative on the battery. Red to positive, and it should have the fan action. So the fan runs. So we know this fan motor is good, it runs, and I know this is a good fan. There was no problems with this motor when I took it out, other than it was making noise intermittently. So now we want to take a look at that fan speed feedback from the motor to the board, because you could have that fan running, but the board doesn't know it's running, so it's going to set an error code and disable that circuit. So we can also check that. So the way this feedback signal works, it's going to send 5 volts, a reference voltage of 5 volts from the control board to the fan. As the fan spins, there's a Hall effect sensor in there, and the faster it spins, it's going to reduce that voltage on that 5 volt reference and bring it down. As the voltage reduces to the control board, it knows the fan is speeding up. Now we can't test it perfectly, but we can see if we got some sort of a signal from it. We're using 9 volts instead of 5 again, so our numbers are going to be skewed, but at least we can see if it's doing something. So I got my meter set here. I'm on 20 DC volts. So I'm going to go ground out of the meter to ground on the battery. And I'm going to go positive into the blue wire coming from the fan. Now we'll power the fan up again. So let's see, we have 3.8 volts there. Back down to 0, but I've removed my power from the fan, so that may screw things up. So what I'm going to do now is we'll just jam that fan up so it can't spin, but we still have power feeding it. We have about 4 volts there. Remove it. We have about 3.7 volts. So it does make a difference on our voltage, depending on what the fan's doing. So again, we can assume that the Hall effect sensor circuit is working. It's not a 100% test, but it at least gives you an idea that something's going on there. Proper way to test this would be in the fridge with the fan running and watching for that voltage to drop from 5 volts on that signal going back to the main board. Head on over to ApplianceTechInfo.com for more appliance repair information. And if you enjoyed this video, don't forget to like and subscribe.